today's our first day looking at limits, and I want to start today looking at our definition. Now listen, it is imperative that you really focus to understand what we're talking about. If you don't get today's lesson, you will be lost the rest of the unit, okay? It is imperative that you get this, okay? Because if you don't understand what a limit is, then you will not be able to use them, okay, or interpret them properly. All right, so I want to start out with the definition. Another thing that's going to be important today is that you pay close attention to the notation that we are using, okay? The notation that we are using. So, first of all, let's start with the definition. The key word in all of this is approach. We're getting close to, we are approaching something, all right? A limit, definition of a limit is this. If f of x becomes arbitrarily close to a unique number L, okay, so f of x is getting close to some value of L, as x is approaching some number c from either side, then the limit of f of x as x approaches c is L. Okay? Now, let's just talk about that for a moment here. What we have is kind of this zooming in process here. As we come in closer and closer and closer horizontally with the x value, the y value is naturally going to come in closer and closer. We can illustrate this just by looking at a box. Essentially what we're doing here is as we get closer horizontally, notice here, let's say that the left side of this box was C. As I get closer horizontally, my y value will get closer to a particular value as well. Okay, so there's kind of this zooming in or honing in on one specific location. As x approaches it, y is going to approach a certain value. Now the one thing that this illustration lacks is the fact that we're not just coming close to it from the right-hand side. We'll actually see that that's a particular kind of limit. We're actually going to zoom in from both sides. All right, but I think that you guys can at least get the initial idea here just by looking at that. Now, the notation. This limit is written as, you see here, it's the limit as x approaches c of f of x equals L. All right, so the limit, Lim, as x approaches c, this is written underneath the letters Lim, of f of x. You have to take the limit of something. It's like a function, okay? We're taking the limit of a function, and it equals L, right? It's equal to a value. Even though we're talking about something that this function is approaching, the limit will equal the value. Okay? Now, let's illustrate this with a piecewise function, x squared minus 4 and 1/2 x minus 1. We're going to take the limit as x approaches 2 of this function f of x. Now you'll notice 2 is the barrier between the two pieces of our functions. Okay? When x is less than or equal to 2, or in other words, everything to the left of 2, we are on this function right here. Okay? All the way until x actually equals 2. If you plugged in 2 here, 2 squared minus 4 is 0. So that's actually the point 2, 0. Okay? However, to the right of 2, we are on this line, 1/2 x minus 1. Okay? So as soon as we pass 2, we jump off of the parabola, and now we're on this line. Okay? Does that make sense so far? Alright, so you guys have dealt with piecewise functions. But here's the key. The limit. The limit. What we have here is we are honing in on this value where x is 2. So for example, you know, here, let's say this was our window right there. Okay? Then there's where our y value is on the left side. Here's where our y value is on the right side. Okay? Notice how it kind of boxes it in there. Actually, there's where it is on the left side. Okay? However, as these two get closer together, all right, horizontally, this is now, let's see right here, it actually went down a little bit. This one came down to here. Okay, so you'll notice this box in the middle here is smaller. If I bring these horizontally even closer to 2, okay, now if I continue to create this box with that's the left side, and then here's where the right side is, you'll notice that box is getting smaller and smaller and smaller. So that's kind of what we're doing by honing in on that x equals 2 value. And the closer and closer we get to 2, we're obviously limited by just what we can see here. But you can see here that it's getting closer and closer and closer to what value? What value is our function approaching here? It's approaching 0. Okay? X is approaching 2. The function is approaching 0. Okay? So that's the concept here of the limit. We're honing in on this one point. Now, you'll notice I've been talking about coming from one side and the other side. And when we're finding a limit, we have to consider what we're approaching from both sides. Okay? Now, those two sides actually have names. Okay? Let's look at this. All right? We have here what's known as the left-hand limit and the right-hand limit. And there's notation that you have to be careful to know related to these. Okay? The left-hand limit is the limit as x approaches c from values that are less than c. Okay, this was part of that video we saw the other day, but I told you we would revisit it. All right? So we have here the limit as x approaches some value c, but we're going it from the left. Okay? And that means the left side of the x-axis is the negative side. Okay? So that's why we put a little negative here next to the c, next to whatever x is approaching. Do not make it a negative c. The negative goes after the c and up as a superscript here. So we're taking the limit as x approaches c from the left of some function f of x, and that's our left-hand limit. Okay? Now the right-hand limit, to the right is the positive side of the x-axis. So we have the limit as x approaches c from the right. We put a little plus sign next to the c here of f of x. Okay? Yes? So there's our left and right-hand limit. Let's take a look at how this works using a table, and then we're going to actually do more of this using a table later on here. Okay? You saw this done once in the video, but let's take a look at this example specifically. We're going to use a table to estimate numerically the limit as x approaches 0 of x over the square root of x plus 1 minus 1. Okay? Now, first of all, let's look at the table that we're going to use. If I were to plug in 0, what would I get?
0.
Yeah, I'd get 0. F of, well, no, I wouldn't get 0. I would get 0 in the numerator and the denominator. F of 0 would be undefined. Okay? It would be undefined. So I'm going to write in here undefined. Or I'll abbreviate undefined there. Okay? Now look at this. This is why it's undefined. Take a look at the graph. And I want you guys to relate. We're going to look at algebraically these limits, how to figure them out algebraically, but I want you to see the graph, see the tables, and see how all this comes together here. Okay? You can see here, there's a hole at 0. It's undefined here. Okay? There's a hole at 0. But you can also see the shape. You can tell that from the left we are approaching a particular value, and from the right we're approaching a particular value. Now just guesstimating from looking at the graph, what would you say we're approaching from the left?
2.
2, and from the right we're approaching 2. So we can guess that the limit is probably going to equal 2. Alright? Well, let's actually look at the table and see why that is. Okay? This is where your calculators come in handy. So, let's get your calculators out. This is going to be really important to being able to do these efficiently, is that you learn how to use your calculators. Okay? The best way of evaluating a number of things quickly, and we're going to do the left side of this table first. The best way of doing these quickly is to first of all graph the function. Okay? So go to y equals, and this was x over, come on, x over, and then you had the square root, but we have a couple of things in there, so we're going to put parentheses. Parentheses, square root of, it was x plus 1, right? Now, be careful here because we want the whole x plus 1 in the parentheses, inside the square root. And then I've got to do a minus 1, and then close the parentheses for the denominator. Okay? Everyone with me so far? That's what it ought to look like when you punch it in. So now hit graph. And it looks like the picture that we were given. So that's good. If it doesn't look like that, you type something in wrong. Now, notice the table, okay? Notice the table. We want to approach 0 from the left-hand side. So they started at 1/100th to the left, so negative 1/100th. Did they have to start there? No, we could have started at, just negative 1/10, and then negative 1/100th, and then negative 1/1000. It doesn't matter as long as you're getting really close. Don't do something like -3, -2, -1. That's not close enough. You've got to really get close to it. So, and also to see the progression, you don't want to just use, I'm going to do negative 0.0003, negative 0.0002, and negative 0.0001, because the decimals are going to be so close together, you're not going to see a movement there. Alright, so that's why they use this kind of exponential type of approach. Alright? So we want to evaluate at negative 1/100th. Okay? So does anyone remember a fast way to evaluate once you have it graphed? Yeah, trace and then type in the value. So trace and negative 0.01, and we get 1.995. Okay? Were you guys able to get that?
Projection, what did you grab?
The original function was that x over. You guys able to get that?
How to type it in wrong, it was different reflections of it.
Well, that's because the minus one is that.
Oh, yeah.
Sergeant?
This is supposed to have, I had the right shoes, like, in all the wrong.
Maybe it's a little monster.
Just sitting there.
We had a legislature meeting to give out donuts at the end, so I just smartest and I raised my hand and I'm like, are you giving me a donut? And like, yeah, I'm like, people are pass it. And Schaefer pulled up, he comes to my house at 3:30, I'll give me lots of donuts. I was like, oh, that's creepy.
Do those exist?
As far as I'm aware, they don't.
Dip the matzo in water, mold it to the
In my 15 years of Judaism, I have not yet experienced the matzo donut. I had a deep fryer.
We had a deep fryer.
Really? Yeah, you gotta make that.
I know, we're gonna make gluten-free.
Alright, are we getting these? If not, ask a friend.
We do have gluten-free matzo. But I think you're right, meeting it's low.
Yes. You're eating cornflakes or something? Because
It's a good snack. It's with peanut butter.
with peanut butter, yeah, peanut butter.
All in this
We can't go that day, really,
So it can be savory or sweet or salty or I don't know about sour.
like sour.
Sour patch kids, sour patch kids.
I wouldn't try that.
Like olives.
Like sauerkraut?
Sauerkraut. You use most hot dog buns.
Yeah,
Really
that's
try.
true.
Now here's the deal, guys. It doesn't matter if you can see the graph really well, as long as the values that you're typing in are within the window. Okay? So even if yours is zoomed out a little bit more, that's okay, because your calculator will at least still see it. Okay? So there's our negative 0.01 is 1.995. Now we have to type in negative 0.001. Okay? 1.9995. Alright?
It's gonna keep going.
Can we guess what the next one's gonna be?
What do you think the next one's going to be?
1.99995.
That's right, okay?
That's 6.
Yeah. Throw it up.
Alright? So those are the values you should get. Did everyone eventually get that?
Yes.
Okay? On the Nspire, you may have to change it because it may be rounding all of those to 2.
It does.
Alright? So you need to go into your settings and change the document settings. You'll see like a float 6.
So go to document settings and change
Document settings, if you see a float 6,
it. You can change it
actually
from
in the
there.
graph you can get
Good
it.
old 283
Hover up,
to 84.
Yeah.
Hover up there.
Tentacle.
It's like 3 pixels per
Inspire.
inch, but it's like it's good quality.
Well, see, it's rounding everything to 2. So
And
if
you
you
can
hover
download
up
games
here,
on it.
Yeah, I've seen someone put
Click on that.
Really?
It may have been like the silver.
See where it says
color
float
one,
6?
Yeah.
Okay, so what am I
Change
changing the
that.
float to?
Float means that it will go up to 6
Just
decimals.
mess around
What's
with
I change it to?
If you scroll down, you'll
Yeah,
see
it's
ones
the
that say,
right?
guys, please be quiet so we can hear. If you scroll down, you'll see ones that say fix.
Oh, fix.
And if you do fix 3, it'll force it to do 3 decimal places.
Don't we need more than 3 for some of these?
Yeah, so I'm just giving an example. You can set it as fix whatever you want.
Go with fix.
Okay? If you ever do computer programming, you guys will learn the difference between floats and that kind of thing too. Alright, did you find that setting here, Elon? Okay.
No, yeah.
If you do fix whatever, it'll just force it. That is the one thing with the end spire. Sometimes in the graphing it rounds way too much, so you gotta adjust it. All right, so listen, right now we can tell what the left-hand limit is. All right? We would say the limit as x approaches 2. How do we show it's the left-hand limit?
Negative.
The little negative after the 2. There you go. The limit as x approaches 2 from the left of f of x equals what?
2.
2. We're getting closer and closer and closer to 2. Alright? Alright, now, we want to do the right-hand side of this table. Okay? Get the right-hand side of the table. So, when you guys type in 0.01,
2.005.
okay? 2.005. Alright?
0, 0, 0.
How about 0.001?
Wait, isn't it
2.0005.
X is approaching 0.
Oh, because in the limit of x.
Oh wait, sorry,
Oh, I just thought.
sorry, yeah. It's x approaches 0 from the left. Thank you. Okay. Now, when you plug in 0.001, what do we get?
2.0005.
Yeah. And how about 0001?
2.00005.
Okay. So what is this getting closer and closer to?
2.
2. All right. So listen. I'm actually gonna change colors here. Okay. So here I'm approaching it from the right. So I would say that the limit as x approaches 0 from the right of f of x equals
2.
2. Okay? Now, at this moment, we've actually confirmed that the limit was what we thought it was. It is 2. And the reason why we've confirmed it is because these are the same. That's the key. You have to approach the same value from the left and from the right. Okay? And if they approach the same value, then that value is the value of your limit. Okay?
What if x approaching 0?
Oh, okay.
That's the limit. Yeah, that was the limit that we were given.
If they don't both approach the same number, then it's what was the term that the guy used? It was
Anyone remember the term?
definition.
Does not exist.
Does not exist, okay? When does a limit not exist? Okay? And Eitan just gave us the first one, or pointed out the first one. If they do not approach the same value, okay? And by the way, this includes if one of them does not exist. In other words, we'll see later on, it's possible for a function not to be defined on one side or the other. Okay? So we'll look at that later. Now, this is the most common one you're going to see. This second one I'll point out. We're going to look at maybe 1 or 2 examples of it next week at some point, but it's really not a very common one, and that is if you have oscillating behavior between 2 fixed values. It's not like going back and forth, but it's honing in on something. It's just literally bouncing between like -1 and +1. And it's not honing in on any value. When you think of oscillating behavior, what do you think is probably involved in functions that do this?
Sine, cosine curves.
Yeah, these are functions that typically involve sine and cosine curves. Not that every sine and cosine curve doesn't have a limit, but the ones that oscillate often are ones that involve a sine or a cosine curve. Okay, so not as common, but it's possible here. Thirdly, if the function increases infinitely or decreases infinitely as x approaches c. Okay? Now I'm going to give an example down here at the bottom. Here's where you may see some different things if you look online, but I am going to have you do it a particular way. Okay? Obviously, if I have an asymptote, let's say here's my asymptote, okay? Let's say it's going like this on one side and like this on the other side. The limit as x approaches whatever that asymptote is going to what?
Oh, it's gonna be infinity, right? Oh, wait.
On the left side, I'm going up to infinity. On the right side, I'm going to negative infinity. So my limit as I approach this value is what?
It doesn't exist.
It doesn't exist. That's rule number one. Okay? Rule number one. They aren't approaching the same thing. Okay? Where it can get a little bit tricky, and this is where, if you look online, you'll see it given both ways. And both of them can be acceptable, but I'll tell you which one I want you to use. Let's say that it's going up on both sides. Technically, they're going towards the same value, all right? So what you'll see is, you'll see some people saying that the limit approaches infinity, okay? The only problem with that is some people say that the limit has to equal a specific number, and infinity is not a number, it's a concept, all right? So they would say that it doesn't exist because it's not approaching one specific value. Okay? That is how I would like you to interpret it. Okay? I would like you, if you see this, to say the limit does not exist. And the reason is because I know Ms. Barheim in Calc Honors, also in IB, and in AP, that's how they'll interpret it. Okay? In college, you may get a professor who teaches it. The limit's an infinite. That's fine. It's perfectly acceptable. But for our purposes, we're going to say the limit doesn't exist. Okay? All right. So now, let's look at an example of number one, the type I was telling you about, where the left and right hand limits are not the same. Okay? Here we have a case where we're looking at the limit of the square root of x as x approaches 0. And you can see here I'm saying that the limit does not exist. Alright? As you just glance at this, what does it look like our function is approaching? As x gets close to 0, what is our function approaching? 0. The problem is, it's only approaching 0 from the right side. Okay? So, our right-hand limit does equal 0. However, to the left of 0, our function's not even defined. So if you have an endpoint like this, you cannot take the limit at the endpoint because, in this case, the left-hand limit does not exist. Okay? So the limit does not exist because one of the sides doesn't exist. Okay? Now there may be applications where you recognize, yes, this is an endpoint, so I'm going to focus on just the right-hand limit, and you want to use the right-hand limit. You can do that. Okay? In certain applications you may do that, but to just say the limit as x approaches 0, you would say that doesn't exist. Okay? Here's another example with what I was just saying. You might see people, if we had the 1 over the square root of x, we had this asymptote at 0. Okay, so we're going up to infinity on both sides of our asymptote. Okay, you'll see some places say that the limit is positive infinity. I would like you simply to say the limit does not exist. Okay? Just get used to doing it that way. Alright? Any questions? Okay. So, I have a handout for you, and they're not numbered, so when you get your handout, take a look at this one first. Okay? I also want to show you one other feature on your calculator you probably haven't used, and that is graphing something that has an absolute value. So, all right, listen. What we want to do here is we want to analyze 4 different limits. Please don't talk when I'm talking. Hello. Thank you. All right, so what we want to do is we want to evaluate the limit as t approaches 1 of the absolute value of 1 minus t over 1 minus t. Okay? Now, if we're graphing this, the first thing that we're going to do is you probably have never graphed with an absolute value. You may not have even used the absolute value on your calculator before. Okay? But if I'm graphing with the absolute value, I'm going to use x instead of t. You have to go to Math and under Number. So hit the right arrow to get to Number, Math, Number, the ABS. Okay? And then whatever you want in the absolute value, you just put it in those parentheses. So we want 1 minus t. Okay? We're going to close our parentheses. And then we want to divide that with parentheses 1 minus t. Okay? Now, before we even hit graph, when t equals 1, what do I get for my function? It's undefined. Okay? So look at our graph. Okay? Kind of an interesting looking graph. So let's sketch this first. We're going to sketch this. So this, I'm going to label this as 1 and this at -1. Okay? So it comes across here, it's a horizontal line actually, and then there's this open point, and then it jumps down to -1, and is a horizontal line that way. Okay? And I'm running through this specifically because I want to show you exactly what I want you to do with the other 3. Okay?
I didn't get the graph.
Huh?
I didn't graph that.
It's probably an issue with the parentheses. Double check your parentheses. Should be parentheses, ABS parentheses 1 minus t. Close your parentheses. Then divided by parentheses 1 minus t. Close your parentheses. You have all the parentheses you need? Some of the newer calculators actually do put in the vertical lines when you hit the ABS button, but
Yeah, that's what it's doing,
okay.
but it's still not the graph.
All right. Okay. Oh, you're just zoomed out super far. Alright, so we already said this thing equals is undefined. Okay? What would be good values to use to approach it from the left? What would this one be?
2.9.
Point
Or
nine.
2.1.
0.9,
There you go.
okay? 0.9 and then,
Point nine
okay? And then
nine.
0.999. Now we don't even need our trace function, right, to figure out what this equals. What does it equal here?
One.
And here? And here? Alright. Good. So at this point up here, use proper notation. Use proper notation. The limit as t approaches 1 from the left of, we'll call it f of t, equals what? 1. Alright, if it's staying the same, it's approaching that same value again. So it's approaching 1. Okay? Now, what value should we use on the table here to the right? Well, how about this one right here?
1.001.
1.1.
Let's make this one 1.1, and then this one would be 1.01. Good, no one said 1.11. We had one first period, that was okay. 1.001. There's almost always at least one person who starts just adding ones, and we're getting further away. Easy mistake to make. Alright, but what is it when we plug in 1.1?
Negative one.
-1, and here it's,
Negative 1.
okay, good. So that means
Do not.
our right-hand limit, hang on, our right-hand limit as t approaches 1 from the right of this function f of t equals -1. So we would say the limit as t approaches 1
Doesn't
Do not exist.
does not exist. We approach different values here. Okay? Now, that's what I want you to do with all of these. You use your calculator to give yourself a little sketch. Find appropriate values for the table, and then evaluate the function at each of those values. And then use that to give the left-hand limit, right-hand limit, and your final answer. Okay? You got 3 of these. I want you to work your way through. And I want you to start now. You can work with somebody to get started on these, okay? And finish these for Monday.